All right, so class has started. Good morning, everybody. Happy Thursday morning. Hope you guys are staying warm. So I have two warm-up problems here that are just kind of what we did last class. So I'm gonna have to go through those kind of quickly because we're moving on to a new chapter, and this is crazy because of COVID. We move really quickly. So we're gonna be moving on to what we're going to be basically. We're gonna have two more topics, big topics, before our final, and this is our second to last one, and that's transformations, and we're gonna talk about that today. So if you guys are big fans of Transformers, whoop whoop, that's what we're going to be talking about. So we'll get started there, and then we'll get into it. I think you guys are going to be it's going to go great. Okay, so that's what we're talking about. Let's take a look at this warm up. As always, guys, make sure you're asking lots of questions, and again, if you guys need help with your homework, please ask questions. I know that some of these homework problems can be tricky because we only see each other for 50 minutes. So yeah, let's take a look. Oop, I'm frozen. You can call me Elsa. All right. So if we want to make these lines parallel, right, we need an angle rule. So the first thing we need to figure out is what angle rule are we looking at. So if I take a look here, they're both on the inside and they don't switch, right? So these would be consecutive interior, right? And so then we just and then again, right, with everything being online, because we're going so quickly, I don't imagine you guys are going to have all of these memorized. So you're going to have to look it up, right? And consecutive interior angles, right, if they are supplementary, then they're parallel. So supplementary means 3x plus x plus 20 equals 180. So if I make these add up to 180, then we're going to have parallel lines. So if I combine like terms, I get 4x plus 20 equals 180 degrees. I'm going to subtract 20. So 4x, and then I get 140. I divide by 4, and I get, wait. Oh my gosh. Okay, I had this in my head, and then, oh, yeah, that's what I did wrong here. Last time I checked, 180 minus 20 is 160. So 160 divided by 4 is 40. Okay, like that. So that's the value of x, right? So the reason we did this, and we can have a reason here, is if consecutive interior angles are supplementary, then parallel lines, right? So that was the base for all of that. So we know that if consecutive interior angles are supplementary, then the lines have to be parallel. And you know what? If x is 40, then they are supplementary, and then they're parallel. Okay, so that's kind of what we worked on last time. And if you guys have questions on that, you should let me know. Like, Kreft, I'm confused why you did that, where you got that. And remember, you guys aren't going to have a lot of time to memorize this. So hopefully you guys have this in your notes so that you can quickly look it up. You can see the visual and be like, hey, I know if I can make these supplementary, then they're going to be parallel. Okay? So that was that one. How are you guys doing there? Are we doing okay? Do you guys have questions? While you guys are doing that, I'm going to set up the second one. Feeling good. Like I should. All right, so I got statements and I got reasons. Okay. And we made a big deal about this last time, right? We always start with our givens first. So I have two givens, right? So I'm going to write those down. So I have angle 1 is congruent to angle 3, and my second given is r is parallel to s. So I'm going to write 1 and 2 over here, and given and given. And then I'm going to update my diagram, right? So it says r is parallel to s. So I'm going to add in, an extra pair of arrows here so I know they're parallel. And then it says angle 1 is congruent to angle 3. Okay, so I wrote down my givens, and then I updated my diagram. Okay, now we got to make a plan, right? So for my plan, I want to get J is parallel to K. So I need an angle on line J, and I need an angle on line K. Well, here's line J, and here's line K. So there's two angles that are highlighted on line J, and there's one angle highlighted here, so angle 3. Well, we want a pair of angles that are connected, so we can use an angle rule. But notice how angle 1 up here in the upper left city is not directly connected to 3, right? I have to go through something to get there. So, but angle 2 in this city is directly connected to 3. So we're going to try to figure out how do we get from angle 2 to angle 3. So that's got to be an angle rule, right? So again, you're going to go to your rules and you're going to look up, okay, angle 2 and angle 3, is this an angle rule? And you're going to find, right, that these two right here are alternate exterior angles. And if alternate exterior angles are congruent, then parallel lines, right? So this is our goal. Our goal is to show that, hey, if these alternate exterior angles are congruent, then these lines are going to be parallel. So, right, so we're just taking a moment to plan. I want these two lines to be parallel, so I'm looking for two angles on those lines. Okay, so to get there, we want these angles to be congruent, right? We want angle 2 to be congruent to angle 3, right? That's what we want. We want them to be congruent, then parallel. So we want those two angles to be congruent. So I take a look. Well, I'm kind of close, right? I have angle 1's congruent to angle 3, but I don't want angle 1. I want angle 2. So I got to figure out, is there a way I can show angle 1 and angle 2 are the same? So then we think, okay, is angle 1 and angle 2 an angle relationship? And by goodness, they are. They're corresponding angles. Right? They're corresponding angles. And then let's check. Are they on parallel lines? Oh my goodness. They are on parallel lines. So if they're on parallel lines, then we know that the corresponding angles have to be congruent. That is, angle 1 is congruent to angle 2. And then if parallel lines, so do we have parallel lines? Oops. That wasn't parallel lines. We sure do have parallel lines, don't we? R is parallel to S. Then corresponding angles are congruent, right? And that's what we have right here. We're saying those corresponding angles have to be congruent because they're on parallel lines. Okay? Well, check that out. Angle 1 and angle 2 are the same, right? Doesn't that just make us excited? Okay, which means they're all the same, right? So if 1 is the same as 3 and 1 is the same as 2, then I know that angle 2 is the same as angle 3. And that was our goal, right? Our goal was to say, are these angles the same? And remember here, you can write substitution or transitive. And I'm sure the big ideas homework only lets you put in one, right? But I'm pretty sure it's a drop-down menu and you can pick which one, or it's just a menu and you can pick which one. Okay. So then we got our goal. So now we can say what we want to say, and that is line J is parallel to line K. And my reason, right? The reason is what we had set out to do in our goal. If alternate exterior angles are congruent, then we have parallel lines. And let's check. Do I have a statement saying alternate exterior angles are congruent? I sure do. And did I say the lines are parallel? I sure did. So that is what we're doing there. And I know these are difficult, guys, and I know that you're like, Kreft, if we just had more time, we'd be a lot better. And I agree. So with that said, make sure if you guys are struggling with your homework assignments to email me, to come to my office hours. We can do the homework together in office hours, right? You guys aren't alone on this. Make sure if you need help, I am here for you. I want to help you. I know this is difficult. I know that we're in a pandemic, and I know that internet's not always working and things are stressful. So please, please, if you want to do your homework with me, come to my office hours. If you have questions, send me an email, okay? All right, so that was the warm-up. Hopefully everyone's had a chance to take a look at that and write that down. But right now, the clock's ticking. Let's get to the new stuff. Okay. So what we're going to be looking at today, so again, for those of you keeping track, We're in a new chapter now. We're in 4.1, and we're going to be looking at transformations. Okay. Now, you guys might know you might think transformations, you might think transformers, right? So transformers is a great thing that we're going to be looking at. So transformers, what do? They change shape, right? You might think of transformations as if someone goes to a beauty salon, they might undergo a transformation, right? And it just means change, right? So you can think of transformation as change. Okay. So it's change of shapes. And that's a very general term, okay? Because a lot of what we're going to be talking about, the shapes aren't really necessarily changing, they're just changing location, okay? So that's what we're going to be doing. So over the next few classes, we're going to be looking at different types of changes, okay? The one that we're going to look at today is what's called a translation. Okay, now this is confusing because I know a lot of you think of translations as like converting from one language to another. That's not what a geometric translation is. A translation is when we move a shape up, down, or left, right. Oops. Kind of got it behind my picture there. So a translation is when we move a shape up, down, or left, right. So if you're playing video games, right, that's the D-pad, right, the directional pad, right? You go up, down, left, right. Okay. We're not going to do, I know some of you guys who are gamers, you guys have like the fancy joysticks that can go 360. That math you guys are going to do when you get to pre-calculus, and you'll talk about movements in degrees, right, with trigonometry that you haven't learned yet. Okay, you guys are going to learn about that next trimester in Geometry B. Okay, but for right now, we're going to keep it simple. We're just going to go up, down, left, right. And if you guys don't know what a D-pad looks like, right, on a video game control, that's what a D-pad looks like. It's just that little cross. Okay, so we're just going to be moving a shape up, down, left, right. Think of it as old school video games. Okay, now to do this, we're gonna have to do things a bit differently this year, right? Shocking, right? But since we all don't have graph paper, we're gonna have to rely heavily on algebra and formulas. Which some of you are like, oh, I don't like algebra. I like geometry. I get it. I'm really sorry. So it used to be really easy with graph paper because you could just count physically on the graph paper. But since we don't all have graph paper, I'm going to show you guys how to do this with equations, okay? And the good news is you don't have to memorize these equations. You just have to have your notes, right? And you just have to be able to look up in your notes, hey, what equations do I need? All right, I'm good to go, okay? So for this next part, you don't need to copy this down. So don't try to copy down this picture. I just want you guys paying attention, okay? You know what? Let's take some notes before we do this. I just realized something. I'm so sorry. We're going to get to that in just a second, but let's take some notes because you're going to be confused unless we take some notes. Okay, so we have translations, move a shape up to right. Okay. So the book uses really weird language. The original shape, okay, that is called the pre-image. Okay, the new shape, that's going to be called the image. Okay, so the original shape is going to be called the pre-image. The new shape is going to be called the image. So that's confusing, and we're going to have to get used to that, right? So the pre-image and the image. Okay, so to do this, there's a couple of things that we need to know. So let's do an example of this. Okay, so let's say I have a shape, the pre-shape, the pre-image, and that is a triangle ABC. So how would I say this? This right here is triangle, which is confusing, right? Because in algebra, you guys learn that as change in or delta, right? But this isn't a Greek letter, it is just triangle. So triangle ABC. So that's my pre-image. Okay. So if triangle ABC is my pre-image, right? That means it's my original shape. Then if I did a transformation to it, then my new shape would be triangle A, and then I'm going to put a little tick mark above it, B, a little tick mark above it, and then C, a little tick mark. This is called my image. And remember, image just means new shape. Okay, so you have your pre-image, that's your original shape, and then you have your image, that's your new shape. You would read this as triangle A prime, like Amazon Prime, right? More math in there. Go on. A prime, B prime, C prime. Okay, so we have our pre-image, we have ABC, and then we have our new image, A prime, B prime, C prime. And like, to tie it back to Transformers, do you guys remember that one of the Transformers is called Optimus Prime? Okay, all this means is that it's this shape, but somehow it was transformed. And so that way we know which one is the original and which one is the transformed shape. Okay, and this is going to be, yeah, I know. You're like, what? What's going on? Guys, this is going to make a lot of sense really easily. It's just when we transform a shape, we're going to have little primes. That's it. That's all I want to do. And the book calls this a pre-image and an image. So let's take a look at an example together, okay? Because this is hard to do, guys. It's hard to do this without graph paper. So let's take a look. So here we go. I'm gonna freeze this. Okay, so what we have here is we have two shapes. Okay, so let me get out my little squiggly. Okay, so notice here in blue, that is my pre-image, right? It is my image. This is what I call my pre-image, because notice how the A, the C, and the B, right? So they have, right? So right here, this is, the A, B, and C, they don't have anything with them. So that is a pre-image. And then I'm just going to, okay, so then what I have over here in red is this is my image. Okay, is the visual helping you guys out a little bit? Do you guys see how this is my image? Okay, notice, do you guys see the little primes? So I'm going to just highlight them. Do you guys notice the primes? Okay, so notice those little primes. Okay, so what this tells me is the blue shape is the original shape, and the red shape is my new shape. This is a translation. Translation. It's really hard to write with my mouse. This is a translation. Oh my gosh, this is an S. Whatever. Okay, so we have a translation, and I'll show you what this means. So a translation means that we move a shape up, down, left, or right. So what we're going to be doing here is take a look at the original A. To get from the original A to the new A, I'm going to be going up 1 and left, left 1, 2, 3, 4. Do you guys see that? So to get from my original A to get to my A prime, I went up 1, left 4. Hey guys, type into chat. Are we doing a little better with an example here? So I'm going from my original A and I'm going to my 4, and then I just have this, right? So I went up 1 and I went left 4. Okay. Now, check it out from all the other ones. I'm going to use a different color now. So from C, I go up 1 And I'm going to see if I can use shift. I can. And I'm going to go left 4. Okay, do you guys see how that worked? Okay, so then take a look at this next one. I'm going B to the new B. I'm going left 4, up 1. Okay, so I went up 1, left 4. Yeah, I'm using, they are really straight lines. I cheated. I used shift. If you hold down shift in drawing programs, it usually forces a straight line. So don't be too impressed. I'm cheating a little bit. Okay, so up 1, left 4. Do you guys see that? All right. Okay, so now that we did all that, let's go back to taking notes. Okay, so, a little too much there. All right, so again, that first triangle, that blue triangle, was my pre-image. The new one, A prime, B prime, C prime, was my image. Okay, so I'm just going to jot this down. I'm just going to make it up really quickly, okay? So A, B, C, and A, okay. Now, can you guys see if I don't put those primes, you have no idea which one's my original, right? So if I don't put the primes, you don't know which one's my original. So if I go like this and put a little prime, then I know that this was first and this was second. I just lost my pen. Give me a second. Ooh. Okay. So this was my first shape. This was my second. This is called the pre-image. This is called the image. Now, what we found here was that to get from A to A prime, I went left 4 and I went up 1. To get from C to C prime, I went left 4, I went up 1. To get from B to B prime, I went up 1, I went left 4. Now, this is too messy. It's hard to see. It takes too long. So what we have is we have a formula. We have a formula for translations. Okay, we have a formula for translations. And that is, notice how when we shift something, it will always connect. So what we're talking about with translations is you take a shape and you move it up, left, right, or not down. So can you imagine if you moved a shape and then they didn't fix up, would it be the same shape, right? So imagine in a video game, right? You move a character and you want them to go up and then to the right, right? That character should stay the same. And I'm going to get that into a little bit. All these shapes should stay the same. They should be congruent. And we're going to be taking a look at that later, right? So all of these shapes are going to be the same. They have to be the same. Okay, right. And I'm sorry I didn't bring that up, but the reason why I didn't bring it up because it will make sense when we talk about it in a little bit. So yeah, right? Okay, so the formula is going to be like this. Notice how when we move a shape, we move all the points, right? Because if I just moved 1 point, then I'm distorting the shape. So it's going to be, so the way that this works is it says, we have a point xy. Okay, so I just have a point xy, and then I'm going to draw an arrow, and then I'm going to say x plus a, y plus b. And then I'll translate this into English. Okay, so right now it's just we have a point xy, and then an arrow, and then x plus a, comma, y plus b. And in English, this is what it means. It means every point So every point, that's what xy means, such that, right, such that is this. So every point such that x plus or minus something and y plus or minus some number. Sorry, I ran out of space. It's just every point such that x plus or minus some number and y plus or minus some number. Okay, so again, so this what this translates to in English is every point such that x plus some amount and y plus some amount, plus or minus. Okay, so if I were to do this, if we were to do this, what's our equation? Our equation here is we took all the points x, y such that I did x minus 4 and y plus 1. Okay, and if you want to convert this to English, that's left 4, up 1. Okay, we're going to practice this a lot. I just thought I would throw you into the deep end and we would try this a little bit. Okay, so the shapes are going to be the same. And all we're doing here is we're going, see how all of them were left 4 and up 1. So this is just the math way. And the reason why we learn this way is if you're a programmer and you're making a video game, this is how you program the movement keys in your game. Right? So basically you have an input telling you to move everything left 4 up 1. Right? So you have a command, right? An input from a computer or a gamepad, and it tells you to go left 4 up 1. And then on the screen, your object will move left 4 up 1. Okay. Let's do some more of these because this is new. Let's keep looking at this. Okay. So I'm gonna use pictures again. Oops, didn't mean to do that. That's confusing. Here, let's I'm just going to erase everything all at once. There we go. So we're gonna stop doing visuals here in a second. This is my last visual. So let's say I wanted to write a rule for this. Oops. Let's say I wanted to write a rule for this one. Okay, so we're gonna write a rule. Okay, so in order to write a rule, we have to figure out first, can you guys type in chat, what's my pre-image? That is, what's my original? So in chat, tell me the color of the shape, that's the pre-image. So in chat, you're either gonna type in blue or red. So what's the color of my pre-image? There we, yeah, and they're just, you guys are, yeah. So my and do you guys see why it was confusing at first, but now it makes sense? So my pre-image is blue. So what I'm doing is I'm going from this blue image to my red image. So I'm going to check. So if I start at C, oh my gosh, that's huge. Okay, let's make that smaller. Okay, so I'm going to start at C. I have to go to my this. Okay, I'm going to start at C. I'm going to go right. So I'm going to go right 1, 2, 3. So that's 3. And then I'm going to go down 1. Do you guys see that? So if I start at my pre-image, C, to get to C prime, I'm going to go right 3, down 1. Now, we can double check some other ones, right? If I'm at D, I'm going to go right amount and then down. So I'm going to go right 3, down 1, right? And then if I'm A, I'm going right 3, down 1. If I'm at B, I'm going right 3, down 1. So notice, we're keeping the shape, right? We're a video game. We're taking this blue shape. We're moving it to the red shape. So if I wanted to write this as an equation, this is what I would do. I would say I'm taking every point, right? I'm taking every point such that I am going right 3 oops, I can undo that. Right 3, and I'm going down 1. Okay, that and we're gonna keep practicing this, but that's what's going on. So I'm taking every point xy such that I'm moving right 3 and I'm going down 1. Okay, so this means, right, this is right 3. Oh my gosh, that was hard. That's right 3 and then down 1. Right? Do you guys see how this is right 3 down 1? How are we doing? You guys can talk to me, you guys can work with me. Are we doing okay? I know that this isn't the best teaching quality, but we don't have graph paper and I'm trying to do my best. Okay? All right. So, again, you have to find the pre-image and the image, right? The original shape and the new shape. I wish they just called it original and new. But you have the pre-image and the image, and it's taking every point xy such that x plus 3, y minus 1. So we're going left. We're going, right 3, down 1. Okay? Okay. So now what we're going to do is we're going to try doing this without a picture. Okay? So we're going to do this without a picture. So you guys can do this. So let's say I'm given shape. Let's do a shape here. I'm given shape A, B, C, D. So this isn't a triangle. It has 4 points. Where, or how about I should say, I'm going to use with vertices. So vertices is a fancy word for points. So I'm going to have A is -1, 2. B is -1, 5. C is 4, 6. And D is 4, 2. Okay, so we have this shape. We're going to apply the translation every point xy such that x plus 2, y minus 3. Sorry, my name's getting in the way. Okay. So we have all of these points, and we're going to apply this translation, right? So we're going to take every point, and I'll write it out in English. We're going to take every point such that, and then you guys tell me, x plus 2, what direction is that? Can you guys tell me in chat, what direction is x plus 2? Am I going left, right, up, or down? Right, so x plus 2, that means right. I'm going to go right 2. And if I have y minus 3, so y minus 3, what's minus in the y-axis, right? Remember, think of this as the y and x axis. It's plus up and down. It's negative left and right, or left and down, right? So if you're having troubles with this, this is what we're doing, right? Up on the y, down on the y. Right on the x, left on the x. So this is going to be down 3. Okay, so this right here, this formula, this is what it means in English. It says apply the translation every point such that we're going to go right 2 and down 3. So I'm going to take every point, I'm going to go right 2, I'm going to go down 3. Well, here's the cool thing about this formula, guys. Notice how all of these points are x's and y's. Okay, all of those points are x's and y's. So this is how we're going to do this. So the image is going to be A prime right? So it's just like a little tick mark above it. Like it's like the apostrophe. If I were the closest symbol on a keyboard is an apostrophe. So how do I do this? Well, I'm going to take my X and Y value and I'm going to plug it into my formula. So this is what I'm going to have. I'm going to have my X value plus 2 and my Y value minus 3. Do you guys see where I'm getting this numbers? Because I'm adding 2, I'm taking every point and shifting it right 2, and I'm going down 3. So I'm taking these values right here, and I'm plugging them in to my formula. Okay, so to get my new answer, -1 plus 2 is 1, and 2 minus 3 is -1, and that's my new A prime. Okay, so what I want you guys to do, so this was for A prime. For B prime, can you guys try that out and type your answer into the chat? And your answer will look like this format. B prime, so B prime, and then you'll have, so use chat, type your answer like that. Dang, some of you guys are super quick. I don't even know if I could type that quick while I was taking notes. So I have 33 students in this class. I should be getting 33 answers. We're taking the coordinates of B, right, my pre-image, and I'm plugging it into the formula. So I know some people are struggling a little bit, so I'll help out. So I have my X value is -1, so I'm going to add 2 to that. My Y value is 5, so I'm going to subtract 3 from that. Okay, hey guys, I should be getting a lot more answers. Come on. There we go, there we go. Okay, and hey guys, what we should be getting is we should be getting 1, 2, because -1 plus 2, right, gives me 1. 5 minus 3 gives me 2. Okay, so that's how this formula works. You just take, and that's what they're saying, every point. So I'm going to take every point, and then I'm going to move it right 3 and down 3. Or right 2, sorry, right 2. So I can really easily do the rest of these. So I'm going to be adding 2 to my X, so that's 6. And I'm going to be subtracting 3 from my Y, so that's 3. And then my D prime, I'm going to be adding 2 to my X. I'm going to be subtracting 3 from my Y. Okay, so this right here, this is called my image or new shape. Okay, and it's not really new as in it's moved. I'm going to say moved, because I don't want you guys to be confused with new. It's not new, it's moved. Okay, so we have, and here I can zoom out just a little bit. So here we have our original, right? This is our pre-image, and then this is our image, right? It's our moved shape. And that's how this formula works. Okay, that's how that formula works. Okay. So we have about 10 minutes left. So we have one more thing to talk about. Okay, that's, so I kind of showed you, right? Like, what did we talk about? We talked about notation, right? The new shape is going to have primes. And then we talked about this formula for translations, right? If we had graph paper, right? If we had graph paper, couldn't we just physically count like I did in my example, right? You would just be like, okay, how did I move? Okay, I physically moved this much, right? But since we don't have graph paper, we're going to be really dependent on this formula. I hope you guys are doing well with this. No one is like screaming like, oh my gosh, this is killing me. All right, so next thing we're going to talk about is composite transformations. Now, some of you might have seen this word composite before. Like you might have heard of a composite metal or a composite plastic. Composite means two or more. Okay, so composite, I kind of put that in the P there. Composite means two or more. So composite means two or more. So two or more transformations. So what's really important here is that you have to go in order. You must go in order. Okay, so if there's transformation 1 and there's transformation 2, you got to do transformation 1 first. Okay, so think about this. If I'm making a video game, that would be a really boring video game if I just hit up on the directional pad and then game over, right? So there's got to be more than one transformation. Like, what if I hit a button and I want that character to jump and then do and then move to the right, like jump over something, right? So that's multiple transformations. They're moving up and then they're moving over and down. Okay, so then we have to program several types of transformations. Okay, so let's take a look at this. So we're gonna have a segment RS such that R is at -8,5 and S is at -6,8. Okay, so here's our example. So we have a segment RS such that R is at -8,5 and S is at -6,8. And again, we don't have graph paper, right? So no graph paper. We got to do this purely with just math, not our eyes and our fingers. Okay? Now you could sketch this really quickly, but you don't need to. And I'll show you why. So we're going to translate. We're going to take every point and we're going to go x plus 5 and y minus 2. Okay, and then second, we're going to translate. We're going to take every point xy and we're going to go x minus 4 and y minus 2. So we're going minus 2 on the y's both times. Okay, so this is a composite transformation because we're doing two translations, right? It's composite. And as we get different types of transformations, right, we might do a rotation. So I might jump, do a rotation, and then come back down. Okay, so as we get more transformations, we'll get more difficult. Okay, so when you do this process, remember, we're going to translate twice. So we're going to end up with, right, if we took photos, we're going to end up with 3 shapes. Our original, what happens after the first, and what happens after the last. Okay, so to do this, we're first going to do the first. Okay, you guys ready? So first, right, we're going to be going from segment RS to segment R prime S prime. Okay, so to do that, we're going to take every point in RS and we're going to apply this formula. Okay, so let's first do R prime. So R prime is going to be R into this formula. So I'm going to have -8 plus 5, right? And remember, calculators, if you're struggling here, calculators help out so much. -8 plus 5, I get -3. And then I'm going to take 5 minus 2.
So I go 5 minus 2, and I get 3. And we're done. That's it. Okay, well, I mean, we got to get S prime, right? So I get S prime. And you guys would tell me if this doesn't make sense, right? You would yell at me, right? I hope so. So I'm going to take, I have negative 6. I'm going to plug that in for my x. So I'm going to go have negative 6 plus 5. So I'm going to have negative 1. And then I'm going to have 8 minus 2. So 8 minus 2. So I'm going to have 6. Boom. We just did our first transformation. We did the translation. So these are the new coordinates of my segment R prime S prime. Now we have to go to our second step. Now remember, in a video game, you don't do one step, teleport back to the beginning, right? Everything is fluid. So when we do our second step, what we're doing is we're going from R prime S prime to, what do you think I'm going to put up here? I'm going to put double prime and S double prime, because this is my second transformation. It makes sense, doesn't it? Right? So this was my first transformation. This is my second transformation. So now what I'm going to do is I'm not going to use RS. I'm covering it up with my calculator. I'm going to take this point and plug it in here, right? So I'm going to take this and plug it in there. So now my R double prime, so I go negative 3 minus 4. So I'm going to go negative 3 minus 4. So I get negative 7. And then I go 3 minus 2. 3 minus 2. I get 1. Okay. So then I do the same thing for S double prime. I'm going to plug in negative 1 minus 4. I get negative 5. I'm going to put in 6 minus 2. I'm going to get positive 4. Okay? And this right here is my final image. Okay? So, for all the homies that are typing their answers in chat, you guys are ballers. Final image, right? So what's happened here is I started here, right? This is my start, right? This is my pre-image. Okay. And then I did one thing to it, and I got to a new position, and then I got another thing. You can almost think of this if like you were playing a game where you had to hop to get to new positions. So I started here, I hopped here, and then I hopped here. And that's my final position. You can think of it kind of like that. Okay? Now, I know we don't have the visual for this, but what's happening is we just took a segment and we moved it, right? So if you guys want a picture of this, don't copy this down. Don't copy this down. Okay? So I'm just going to sketch a really rough graph of this. So what this image kind of looks like, it kind of looks like this. And then we shifted it right 5, down 2. And then we shifted it left 4, down 2. Sorry, I forgot to put the primes. So for my visual learners out there, it looked something like this, right? So the first thing we did is we shifted to the right and down, and then we shifted to the left and down. Okay, so that's all you're doing. You're just kind of like to the right and down, and then to the left and down. Oh no, oh no. So I'm sorry that the computer died. Remember, this video will be up on YouTube. That's why I record everything, because I know the internet is stupid and does stupid things. So I'm really sorry that their computer died. Hopefully they can get that figured out and access the YouTube video. Okay. So, hey guys, that is everything I wanted to cover today. So just to recap everything that's really important, okay? So the really things that are important. The original shape is called the pre-image. The new shape is called the image. So an example of this is triangle ABC is my pre-image, and then triangle A prime, B prime, C prime is my image. Okay? We have this formula, and all that means is you're taking every point such that X plus or minus something and Y plus or minus something. Okay? So the example here is I went left 4 and I went up 1. Okay? Then, right, we practiced one of those. We can do it without a graph. And then composite transformations, you must go in order. So you just go one at a time, but you don't go back to the start. You recycle. You say, okay, I went from RS to R prime S prime, and then I'm going from R prime S prime to R double prime S double prime. Okay? Hey, just one other thing before people leave. I want to make sure people are super clear on this. Make sure you guys are doing your homework. If the homework is difficult and you're stuck and you don't know how to do it, email me. I can help you. I will help you. Okay? Also, all my office hours are in the morning. So if you guys need help, please stop by in the morning. We can sit down together and we can do you can do your homework together. We can get through those tough problems. So please use me as a resource. I want to make sure that you guys are getting this stuff. It is super important, okay? I want to make sure you guys are successful and you feel good about it, okay? So with that said, you do have homework. It's going to be due on Monday. Please send me an email if you need help. But until then, stay warm, take care, and